Let's take a look at Chapter 3 Task Review. Okay, and let's see, I'm ready to start. Okay, find the zeros for a given polynomial function and give the multiplicity for each zero. State whether the graph crosses the x-axis or touches the x-axis and turns around each zero. Okay, so we got f of x is equal to x to the third minus 6x squared. I think that says plus 9x. And the instructions say find the zeros. So let's start there. To find the zeros, you set the function equal to 0. So we got x to the third minus 6x squared plus 9x equal to 0. Now right away I notice I'll have an x, so I can factor out a GCF. So I factor out an x, and that gives me x squared minus 6x plus 9 equal to 0. Now looking at what's inside the parentheses, this is going to be the PSD, because we have x squared, x, no number in front of our x squared. PSD, remember we take a number at the end, the 9, come up with our 3 columns. We list all products give us 9. We got 1 times 9, 3 times 3. Add them, S for sum. 1 plus 9 is 10, 3 plus 3 is 6. Subtract them, D for difference. 9 minus 1 is 8, 3 minus 3 is 0. Number we're looking for is a number in our middle term, which is 6, which is right here, which means we use 3 and 3. So I got x, 3, x, and 3. Larger number, they're both 3, so they're both the same, but a larger number is always the same sign as the middle term. Middle term's negative, so this will be negative. Number of circles in the S column, S for same signs, so this will be negative also. So we'll have x times x minus 3 squared equals 0. Now, zero factor property. When you get 0 on one side and you factor the other side, you set each factor equal to 0. So I'll set x equal to 0, and I'll set x minus 3 equal to 0. Which gives us 0 and 3. And those are our zeros. Multiplicity at leftmost 0, multiplicity at rightmost 0. Okay. Well, these are going from the smallest to largest, so this is my leftmost, this is my rightmost. Our multiplicity is the power that's on this. See how there's a second power on this one? So our multiplicity here would be 2. If I were to put a power on the x, it's like x to the first. So our power is our multiplicity, so this would be multiplicity of 1. So it would have 1 there and 2 there. Determine the graph crosses are leftmost and rightmost, so crosses or touches. Or touches or crosses. If your multiplicity is 1, it always crosses. If your multiplicity is 2, it will touch. So, let's see, leftmost 0, which is this one, we'll say crosses. Then the rightmost one touches. Our next question. Solve the rational inequality. We got x plus 1 over x minus 9 is greater than 0. Now, solving our rational inequality, we'll go through our steps. First step is to get everything on the left side, 0 on the right. That's done. Second step is to get a single fraction. That's done. Then we need to factor the top, factor the bottom. Well, the factor as much as they can be, and set each factor equal to 0. So I'll set x plus 1 equal to 0, and I'll set x minus 9 equal to 0. Which gives us x equals negative 1, and x is equal to 9. Now these are our critical values, so we want to put them on the x-axis. And these split them up into intervals. Clear over here is negative infinity, clear over here is positive infinity. Now we want to graph this, Graphing a rational inequality, the key to it is put parentheses around the top, parentheses around the bottom. So put parentheses around x plus 1 and parentheses around the x minus 9. So go to y equals, clear, do a beginning parentheses, x plus 1, closing parentheses, divided by, beginning parentheses, x minus 9. Then closing parentheses. And then graph. Well, we got a critical value of -1. -1 is right here. And if I look over here, I see it's above the x-axis. So it's above. Now between -1 and 9, well, or I guess actually here's -1. Long day. Okay, here's -1, and 9 is over here, and I see it's below. Now these do alternate, but unfortunately I can't see the piece of the graph over here. But if I do zoom and choose zoom out, choose 3, and then once that comes back, you press enter one time, then I see that up here it's above. They alternate. I'm not sure if I've ever seen a rational. I suppose I could design one, but most of them alternate like this. This is above, this will be below, and this will be above. Now to set your calculator back, you do zoom and you choose 6 for Z standard. That'll always set your standard viewing window back to -10, 10 on the X and Y axis. Okay, now it's a greater than, so our answer is going to be above the X axis, which is here and here. Well, this first interval is from -infinity to -1. The second interval is from 9 to +infinity. Infinities always have parentheses on them. This is a greater than. When you have a greater than, it puts parentheses on your numbers. And then if you got 2 or more intervals, you connect them with a union symbol. Okay, let's see. Solution set, type your answer in interval notation, type an exact answer, use radicals as needed. Okay. So I'll come here and I'll put a beginning parentheses, -infinity, comma, -1, close parentheses, union, and then I'll do my beginning parentheses, 9 to infinity. So 9 comma, then infinity, and then closing parentheses. Okay. And then choose the correct graph. These are parentheses, so they're or those are parentheses up there, so it has to be parentheses down here. I think it's B, but let me see. Okay, that's -1, so x is less than -1. Yeah, that's right. And x is greater than 9, so that's correct. Okay, next question. Find all zeros as polynomial function. So we got 5x to the 4th minus 84x to the 3rd plus 278 x squared plus 444x plus 77. Okay, and want to find a 0, so we're setting it equal to 0. Now we need to go put our polynomial on y1 and 0 on y2. Okay, so I'm going to press my y equals, press my clear, and then I got 5x to the 4th, so 5x caret 4 minus 84 x to the 3rd, so x caret 3, plus 278 x squared plus 444x plus 77. Now I already have 0 on y2, but if I didn't, I would down arrow to y2 I would down arrow to Y2, press clear, and put a 0 there. Now we'll do second trace, choose intersect. Looks like -1 is our first answer, and 10, 9, 8, 7. -1 and 7. Let's do enter on first curve, enter on second curve, put in -1, and that's our first answer. Now let's do second trace, choose intersect, enter, enter, and then I'll put in 7. It comes back and tells us the intersection is x equals 7. So, looks like -1 and 7. Well, we'll start off putting one of the values into synthetic division. I'll start with -1. Doesn't matter which one you start with. So we got 5, -84, 278, 444, and 77. And this was x to the 4th at this point. So we add, multiply, -1 times 5 is -5. Add, -84 and -5 is -89. Multiply, -1 times -89 is 89. Add, I think that's 367. Multiply, -1 times 367 is -367. Add, and we get 77. Multiply, -1 times 77 is -77, and add, and we get a 0. Now you have to get a 0 there. If the calculator told you it's an answer, then you have to get a 0 there. So that's kind of a check. Now we started with x to the 4th. We're now down to x to the 3rd. And we're going to plug in our second answer in the line we just found. So I'll add, multiply, add. What was that, -54? Multiply, 7 times -54. Let me double check that. 8, 2, 35, 36, 37. -378. Okay. And then add. And, 11? -11? And then multiply. 7 times -11 is -77. Boy, those numbers are very easy. Then 0. And again, a 0 there means we found our second answer. So x equals 7 is our second answer. We're now down to 5x squared minus 54x minus 11 equal to 0. And this looks like it would have factored, which means I could have got more answers via my calculator. And now that I look at it, I do see the bold right here. I didn't see that at first. So if I do second trace and choose intersect, enter on first curve, enter on second curve, let me put 0 in for the guess. Sure enough, there's another answer right there. -0.2. So let me do a second mode to exit out, and then do math, enter. And we get x equals -1/5. Now, let's see if we can find another answer via the calculator. I'll do second trace, choose intersect, enter, and let me put 1 in for the guess. See if there's 1 on this side. -0.2. I would have expected that to be another answer there, but okay, well, I guess that's the only one we got. So let me actually, x equals -1/5. Let me get rid of that. And I'm going to plug in the -1/5 in the line I just found. Because we're now down to x squared. So I'll add, multiply, -1/5 times 5 is -1. Add, -54, -1 is -55. Multiply, -1/5 times -55 is +11. And add, -11 plus 11 is 0. Which means that x equals -1/5 is our third answer. And the answer I was having trouble with, doesn't look like it's even on the screen, but we're down to the x level now. Each answer you find takes it down one more power. So we got 5x minus 55 equal to 0. So we got 5x is equal to 55 Divide both sides by 5. And we got x is equal to 11. And those will be our 4 answers. Okay. Zeros, okay. You type zeros or simplified fractions. Use commas to separate them. So -1 and 7. -1/5 and 11. And next question. Okay, solve the polynomial inequality. So we got x squared minus 12x plus 27 is greater than 0. Now our first step is get 0 on the right side. Get everything over on the left side. We got that. Our second step is to factor this. This factor is using the Pst method, and factors as x minus 9 times x minus 3. Now set each factor equal to 0, so I'll set x minus 9 equal to 0, and I'll set x minus 3 equal to 0, which gives us x equals 9 and x is equal to 3. Now we want to put those on the number line here. So I got 3 and I got 9. Our x-axis, and these split them up in intervals. Clear over here is negative infinity, clear over here is positive infinity. Now it's an x squared. There's a positive number in front of your x squared, which means it's going to open up. And our critical value is where it's going to cross, so the graph, without even going to the calculator, will look like that right there, more or less. Now our problem's a greater than, so we're looking for above the x-axis. Well, it's above here, and it's above here. So this interval is from negative infinity to 3, and this one is from 9 to positive infinity. Infinities always have parentheses on them. This is a greater than, which means I'll use parentheses here, and then a union symbol in between them. So negative infinity to 3. Then a union, and then I'll do a beginning parentheses, 9 comma infinity, close parentheses. Okay, that looks right. And then our graph, looks like this one, C. Next question. Let's start a new page here. It says find the slant asymptote of the graph of the rational function. Okay. So we got f of x is equal to x squared plus x minus 30 over x minus 7. Now you have a slant asymptote when your degree at the top is exactly 1 larger than the bottom. Degree at the top is 2. Degree of the bottom is 1. So degree of the top is exactly 1 larger. We're going to use long division, and then we're going to drop the remainder to find a slant asymptote. Now remember, you look at the first term of each side, what goes up on top. So you ask yourself, what times x gives you x squared? And that's x. Now whatever we put up on top, we multiply by what's on front. So x times x is x squared. X times negative 7 is negative 7x. Now we're going to subtract that line, which means flip signs, so it becomes negative, this becomes positive. X squared minus x squared drops away, x plus 7x is 8x, and then I'll bring down the minus 30. Again, we look at the first term of each side of what to put up on top. You ask yourself what times x gives you 8x, and that's 8. Now whatever we put up on top, we're going to multiply by what's on front. So 8 times x is 8x, 8 times negative 7 is negative 56. We're going to subtract that line, which means flip signs. So this becomes negative, this becomes positive. 8x minus 8x drops away. Negative 30 plus 56 gives us 26. And this is our remainder. Your remainder is when the degree of this is lower than what you're dividing by. Degree of 26 is 0. Degree of x minus 7 is 1. So drop the remainder, and our slant asymptote is y is equal to x plus 8. So x plus 8. Then it says use slant asymptote to graph the rational function. First determine the symmetry of the graph of f. I don't see it as even or odd in terms of the symmetry. So the graph has neither y-axis nor origin symmetry. Now the y-intercept. To find the y-intercept, you always plug 0 into the other variable. So plug 0 in for x. And we're going to replace f of x with y. So we got y is equal to 0 squared plus 0 minus 30 over 0 minus 7. Which gives us y is equal to 30 over 7. Type an integer, use comma separate answers, so it doesn't look like they want it in point form. So 30 over 7, famous last words. Oftentimes I do want those in point form, but it didn't specify here. Now the x-intercept. For the x-intercept, we always plug 0 into the other variable, so we'll plug 0 in for y. Remember, y is over on the left side, the f of x. So I got 0 is equal to x squared plus x minus 30 over x minus 7. Now I can multiply both sides by x minus 7 to get rid of that fraction. And that x minus 7 cancels that x minus 7. 0 times anything is 0, so we got 0 is equal to x squared plus x minus 30. Now factor that. That factor is using the PSD as x plus 6 times x minus 5. Set each factor equal to 0. X plus 6 equals 0 and x minus 5 equal to 0. And we got x is equal to negative 6 and x is equal to positive 5. So x-intercept. Negative 6 and 5. Okay, now our vertical asymptote. Vertical asymptote is you factor the top, you factor the bottom. Top part we already said factors as x plus 6 times x minus 5. Bottom part factor as much as it can be. Step 2 of finding the vertical asymptote, you cancel if possible. Well, I can't cancel here because they're not the same. Step 3, set your denominator equal to 0 and solve, and you get x is equal to 7. Now horizontal asymptote. You look at the degree of the top, degree of the bottom. Degree of the top is 2, degree of the bottom is 1. When degree of the top is larger, there is no horizontal asymptote. So there's no horizontal asymptote. Okay. Well, our vertical asymptote we said was, what did we say it was? 7. So I'm looking for one that has a vertical asymptote of 7. That's not A. Might be B. Might be C. Might be D. So it's between these. Now y is equal to x plus 6, I think was our, no, y is equal to x plus 8 is our slant asymptote, which means it passes through 8. Let me make this a little bit bigger so I can see it. Yeah, that looks like y is equal to x plus 8 there. Okay, that's a possibility. We'll come back to that. No. Yeah, and this one, let's see what this looks like. That looks like a possibility too, but it doesn't have any piece up here. And these exist everywhere, so B would be our answer. Not a big problem. In this one, we want to find the coordinates of the vertex. So we got f of x is equal to 3x squared minus 12x plus 9. Now we're going to use a vertex formula. And our first step in the vertex formula is identify a and b. Now a is whatever number's in front of your x squared, which is 3, and b is whatever number's in front of your x, which is negative 12. Then we want to plug that into negative b over 2a. So I'm going to have negative 12 over 2 times 3, which gives us 12 over 6, or 2. Now this is the x part of our vertex. So we want to take that and plug that back into our original function. So we got 3 times 2 squared minus 12 times 2 plus 9. 2 squared is 4 times 3 is 12 minus 12 times 2 is 24 plus 9, which gives us negative 12 plus 9, or negative 3. So our vertex will be 2, negative 3. And the next question. Okay, determine without graphing whether the function has a minimum value or maximum value. Has a negative number in front of the x squared. Whenever you have a negative number in front of your x squared, the graph opens down, which means it has a maximum. Okay, and then it's asking what the minimum maximum value is. So we need to find the vertex. That's how we get the min or max. So we got f of x is equal to negative 2x squared plus 12x minus 6. Now again, we're going through these 3 steps here. Identify a and b. A is negative 2, b is 12. Step 2 is find negative b over 2a. So we're going to have negative 12 over 2 times negative 2. Which gives us negative 12 over negative 4, which gives us 3. And then we want to plug that back into our original function, the 3. So we're going to have negative 2 times 3 squared plus 12 times 3 minus 6. Now 3 squared is 9 times negative 2 is negative 18 plus 12 times 3 is 36 minus 6. Negative 18 plus 36 is positive 18 minus 6 is 13. I don't think that's right. Let's see. Negative 18 plus 36 is 18. Minus 6 is 13. 12. I knew it did. It didn't seem right. Okay, so that's values 12 and occurs at x equals 3. That's off of step 2. Okay, domain of f. Well, the domain is negative infinity to positive infinity. It always is for quadratics. If you look at the graph, it makes sense. Now we said that it has a minimum maximum value of 12. So for the range is your y values. We're going to go from negative infinity and then comma and then put 12 in with a bracket. There we go. And then the next question. Okay, solve the given polynomial equation. Start a new page. So we got 2x to the third minus 5x squared minus 5x minus 1 equal to 0. Okay, the fundamental theorem of algebra says your largest power tells you how many answers you're going to have. So it means we're going to have 3 zeros, 3 answers. So let's go plug this in the calculator. So press my y equals, press my clear. 2x to the third minus 5x squared minus 5x minus 1 and 0 on y2. Okay, so we'll do second trace, choose intersect, looks like, don't know what that is. Enter on first curve, enter on second curve, let me put in -1. We get -0.5. Okay, so I'm going to exit out, do a second mode. Whenever you get decimals that change in fraction, you exit out, second mode, and then you press math, enter. And that gives us -1/2. Let's see what other answers we can get from the calculator. So do second trace and choose intersect. Looks like over here is like 4 or 3. So we do enter on first curve, enter on second curve, and I'll put in 3. That doesn't look promising, but let's try to change it. So I'll exit out, do second mode, and press math, enter. Now it doesn't change to a fraction, so we can't use it. So it looks like we found one answer, which is fine. We'll plug that into synthetic division and see what we end up with. So we got 2, -5, -5, -1. So we'll add 2 plus nothing is 2. Multiply. -1/2 times 2 is -1. Add -5, -1 is -6. Multiply. -1/2 times -6 gives us +3. Add. -5 plus 3 is -2. Multiply. -1/2 times -2 gives you a +1. And then add. -1 plus 1 gives you 0. So our first answer is x equals -1/2. Now we started out as x to the third, so now we're down to x squared, and this is x, and this is our no x, our constant term. So we'll have 2x squared minus 6x minus 2 equal to 0. Now I could factor a 2 out, GCF, and that leaves us x squared minus 3x minus 1 equal to 0. Now this will not factor any further, which means I have to use the quadratic formula to solve it. Now the 2 we can just drop. Our quadratic formula is based upon what's inside the parentheses. So a is going to be the number in front of your x squared, which is 1, the invisible 1. B is whatever number is in front of your x, which is -3. And C is your number at the end, which will be a -1. Quadratic formula is -b plus or minus square root of b squared minus 4ac all over 2a. Then we'll plug in the values. So we got negative, and I'll put parentheses in first before I plug in my numbers. Always a good idea if you mess up on signs. Okay, b we just said was -3. So everywhere I had a b, I'll put in -3. A we said was 1, so everywhere I had an a, I'll put in 1. And c we said was -1. So everywhere I had a c, I'll put in -1. Well, negative gives me +3, plus or minus. -3 squared is 9. -4 times 1 is -4, times another -1 gives me a +4 over 2. Which gives us 3 plus or minus square root of 13 over 2. The plus or minus there accounts for our other two answers. How does they want us to enter this? Use comma, separate the answers. Okay, so I guess I need a fraction. Three minus square root of 13. So 3 minus square root of 13 over 2, comma, I'm going to do my fraction, 3 plus square root of 13 over 2. And next question. Okay, find the vertical asymptotes. Well, our vertical asymptotes say to factor the top, factor the bottom. That's done. Step 2 says to cancel. Well, that's done. Well, it's not done, but as much as it can be. So step 3 says to set your denominator equal to 0 and solve. So we got x times x plus 9 equal to 0. Now this is already factored, so I can set x equal to 0 and x plus 9 equal to 0. Which gives me x equals 0 and x is equal to -9. So, right here, C. Okay, the vertical asymptotes are 0 and -9. Now these are both vertical asymptotes. And there are no holes. Holes correspond where you got something that cancels away. And I don't know if we'll have an example of that, but for example, if this had been x plus 9, this would have been x plus 9, the 9s would have canceled. So I wouldn't have put the negative 9 here into vertical asymptotes. I would put them under a hole. Okay, next question. Find all the zeros of this. Okay, so let me oh, there's number 9. Okay, I guess number 9 wasn't a whole lot of work. Number 10, we got x to the third minus 3x squared minus 33x plus 35 equal to 0. Let's plug this in the calculator and see what we get. So press my y equals, press my clear. I do x caret 3 minus 3x squared minus 33x plus 35. And I'll do second trace, choose intersect. What is that, negative 5, 1, and something. Let me do inner on first curve, inner on second curve, and I'll put in negative 5. Well, my eyes usually aren't that good to see that. It doesn't matter, you don't want to actually input the guess as your answer. It'll find the one closest to it in theory. This one looks like 1. So we do a second trace, choose intersect, inner, and I'll put in 1. Yeah, that looks promising. Next one looks exact too. I think it's 7. But let's do second trace, choose intersect, inner, and then I'll put in 7. And it comes back and tells us 7. So our answers are negative 5, 1, and 7. Negative 5, 1, and 7. Okay, here's the time of truth. Let's see which ones I missed. I'm kind of sleepy right now, so wouldn't surprise me if I don't miss a little bit. Let me do the Smith test. I missed 2 of them. Got 75%. Boy, how did I miss that many? Let's go with this. You answer. I didn't answer that. I know I entered this in. Maybe I didn't click the box. I don't know about that one. I know I didn't put the solution set as the empty set. Liar. Okay, this one I just did. What did I do? Oh, I didn't put in my negative. Negative 1/2. Okay, let's see how I did on this one. Okay, vertical asymptotes are, they want x equals and x equals. Oh, that's just great. Did they tell us that? Type an equation. Type an equation. Okay, it helps to actually read the instructions. I came up with the negative 9 and 0, but I didn't put the x equals. I guess I just typed in negative 9 and 0. Picky. Things like this, I didn't mean to make these mistakes here. This one here was an entry error. This one here is just sloppiness. I just left off the answer. It was on my notepad. And this one, I'm guessing I didn't select the A. I just entered the value in here. But I remember entering that value. I don't think we still have that on there. But if you have something like this, especially this one here, where you just forgot to put the x equals on there, don't take 0 on that. Email me and I'll correct that, and don't redo the test just because you forgot to put that. It isn't real clear. I mean, it does say type an equation, which these are equations, so I just didn't read directions. But anyway, that's our Chapter 3 test review.